Thanks. Okay. So did you like load up way back when on these half sheets?
I have a lot.
So that's why I ran out so fast. Beef.
I mean,
All right. So going over the warm up real quick. You're given velocity, not position. So make sure you read carefully. I could give you the position function. I could give you the velocity function. I could give you the acceleration function. Probably I won't until we know integration and can go backwards. So that won't be this semester. But I could give you either position or velocity or acceleration as the given function. Here, you're given the velocity. So when I say find the velocity, just use what we gave you. And so just plug 2 into the function. 2 plus 1 is 3. 2 minus 1 is 1. So your velocity is 3. Done. In part B, you want to find the acceleration. Acceleration's relationship to velocity is what? Derivative. So acceleration, column A, is v prime. And to get v prime, I have to use what rule? Quotient rule. So low, v high minus high, v low over low, low. Looks like that when you set it up. And then you go and distribute out your numerator, and you get t minus 1 minus t minus 1 over quantity t minus 1 squared. Please be careful. What's t minus t? 0, not negative 2t. So be careful there. I saw some negative 2t's up here. Negative 2 only over t minus 1 squared. That's your acceleration. So a, or v prime, equals 2, negative 2 over t minus 1 squared. We want the acceleration at time 2. So plug in 2 for t, and you get negative 2 for your acceleration. Done. Any questions with part B? Part C is the part of it getting faster or slower. You don't just look at the acceleration only. You got to look at both the velocity and the acceleration together. So if the acceleration is negative, you could be speeding up if your velocity is also negative. That would be like acceleration being negative just means you're accelerating in the negative direction, like to the left. If you were moving in that direction as well, you'd actually be speeding up in the negative direction. So think like in a car, you could be moving forwards or backwards, and if you're in reverse, you're moving backwards. So if you're in reverse going backwards, and then you're stepping on the gas, you're going to be moving backwards faster and faster. You're speeding up despite having negative acceleration. So just because you have negative acceleration does not mean you're slowing down. It means you're slowing down here because your velocity is positive. So in part C, we're slowing down because velocity and acceleration have opposite signs. So they're working against each other. So if velocity and acceleration have the same sign, then you're speeding up. If they have opposite signs, they're working against each other and you're slowing down. Part C is an AP-style question. I am preparing my AP students for the AP exam in 3 weeks, and on one of the free response questions, that was one of the parts of like, hey, acceleration, velocity, are you speeding up or slowing down? And understanding the relationship between velocity and acceleration. Get out your homework from last night. .45. So 45, we have 4th root of t. Is that plus 6 cosecant t? All right, what else? 37. I got x squared minus c squared over x squared plus c squared. Or did I reverse that? No, it's plus on top and minus on the bottom, right? Yeah, and c is just some unknown constant. It's just a number. 47, somebody say? Y equals 3, quantity 1 minus sine x over, what is it, 2 cosine of x. Anything else? 29, 43, so 29. We did, no, I did that in block 3. 29 f of x equals, what is it, 3x minus 1 over root x. And 43 is negative x plus tangent x. And 55, 35, it wasn't 55. 35. And we're out of space here. 35, we have three things getting multiplied, so that was fun. 2x, what is it, 2x cubed or 2x squared? Cubed plus 5x, and then in here, x minus 3, and then in here, x plus 2. All right. And that's all. So if you have other questions, come to office hours. 4 points? Whoa! All right. Who's got 4 points already?
No. I haven't got the book.
Rachel, go ahead. Tanika, go ahead. Prince, go ahead. Raisa, go ahead. Akshay, go ahead. Japhne, go ahead. And you two have at least as many or more than everybody else is up here. I think. There it is. All right, so we have Tanika, and Prince, and Daphne, and Raisa, and Akshay, and Rachel. Rachel, and Akshay. Hopefully one of the things that we get out of this is seeing there's usually an easier way of doing things. So, like for example, with 35, you could do product rule with that, but there's like 3 things getting multiplied. So doing product rule with 3 things is really messy. So probably you're better off just distributing it all out and then just doing basic power rule. Or like 47, you could do quotient rule, but you could just divide that out. 47, I mean. 37, you have to do quotient rule. Prince, what's the derivative of a constant?
Oh. Yeah.
So 47, Japanese doing it let's just power through with your quotient rule. But you could do that, like break it up into 2 separate fractions and turn cosine, flip it up and make it secant, or sine over cosine, think of that as tangent. So one of the things that we'll do here is kind of see, okay, we did it this one way. Is there a less painful, more efficient way to do the same thing? Maybe your answer looks a little bit different, but who cares? If you're doing a correct pathway, then you're good. Oh, thank you. Wait, what?
Huh? I didn't do this. I didn't do it correctly.
Evidently, that's pretty clear. Yeah, go sit down. That's you're hurting me. All right, Narose, how many board points do you have? No, sit down. This is taking too long. I'll just do it.
There are people not reading this.
Yeah, it's taking too long. All right, 45. Who are you? Talk to us.
Okay, so the first thing I just want to do is set the derivative of that, and first simplify it's t over 1/4.
T raised to the 1/4.
Oh, right, yeah. And so then put that do the product power rule, and 1/4 on the front, which is 1/4 t over raised to a negative, and then minus the 1/4, which is negative 3/4, and right. And then so then on the second part of it, the derivative of secant is oh my fault. Cosecant is negative cosecant cotangent. And then just bring that down. And then since the what's it called? Exponent of the t is a negative, you just drop it down.
Ta-da! Good stuff. So you don't need to use product rule or quotient rule here. You just take the derivative of each term separately, make sure you know your trig derivatives, and you're good. 37. All right. First of all, what's the derivative of a constant? 0, not 1. Secondly, is that the quotient rule? No. So he just did the derivative of the top incorrectly and the derivative of the bottom incorrectly and said, I'm done. And then he was doing quotient rule for some reason. That was very bizarre. So thank you for that. That's okay. You got your board point? I'm not going to erase it. Too much work. So f prime of x, quotient rule right off the bat, what's low? All right, x squared minus c squared. It's what you see down there. What's d high? 2x, because what's the derivative of c squared? 0, because c is a constant, and so c squared is a constant. The derivative of a constant is 0. So c squared goes poof when you differentiate it. Then, what's high? X squared plus c squared. What's d low? 2x. Low, just write this out and square it. Then you distribute out the numerator and combine like terms. So, stuff on the bottom. Distribute out the numerator, you get 2x cubed, and then minus 2xc squared, and then minus 2x cubed, and minus 2xc squared, right? And that's the same. So when you combine like terms, what happens with a 2x cubed? Cancels out. What happens with a minus 2xc squared? Combines, you get negative 4xc squared over x squared minus c squared all squared. So that is f prime. So you just treat c as though it's just a number, but instead of having an actual number there, you just have c squared instead. 47. Japanese, talk to us. So in the thing being the answer key? Yeah. There's a sneaky Pythagorean identity on top. What if instead of a 3, we take out a negative 3? That'll make it a little more clear. If we take out a negative 3, then what do we have in here? Cosine squared x minus sine x plus sine squared x. And what's cosine squared x plus sine squared x? 1. So we have a 1 minus sine x in here. We have negative 3 quantity 1 minus sine x all over 2 cosine squared x. So that would be a simpler way to write this. We could break that apart into multiple fractions and make it look different. Now, while they were putting this up, I was saying you don't have to do quotient rule here. You could, from here, break this apart into 2 separate fractions and say this is 3 over 2 cosine x and minus 3 sine x over 2 cosine x. And an advantage of doing that is then you can say, well, let's just try to do a couple trig derivatives, because if cosine x is in the bottom and I bring it up, well, what's the reciprocal of cosine? No, what's the reciprocal of cosine, guys?
Oh.
Secant. So this is 3 secant x over 2. And what's sine over cosine? Tangent. And then you can just do the derivative of that guy using your trig derivatives. So if you See, hey, my denominator is only one term. It's a trig thing, but I can still maybe avoid having to do a quotient rule if I get creative, divide out the fraction into two separate pieces, and then say, well, 1 over cosine is a secant, and sine over cosine is just tangent, and then I'll come over here, and what's the derivative of secant? What's the derivative of secant? It's tangent secant, but normally I write secant tangent. So derivative of secant is secant x tangent x. And what's the derivative of tangent? Secant squared x. So that would be another way to write the derivative. So 2 pathways. I think this way right here is a little easier. It's more efficient. It's fewer steps. But it requires more knowledge of your trig identities. Here you just plow right through quotient rule. That's fine. Nothing wrong with that. And you get a different looking answer. They're both right. Guy making the key has to take into account both possibilities and when he goes to grade stuff. Any questions with 47? You have to know your trig identities and you have to know your trig derivatives. On your quiz, I'm just going to tell you right now, on your next quiz, there's going to be some fill in the blank stuff. Hey, here's a trig. I'm going to tell you. Here are trig identities. Fill in the blanks. And I'm going to also have trig derivatives. Here are trig derivatives. Just tell me, run down the list. What are the derivatives of sine and cosine and secant and cosecant and so on? Before we even get to like actually doing math, you have to know them. So make them flashcards if you need to. Look at them, study them, make sure you know your trig identities and your trig derivatives. You have to know them. 29. Risa, talk to us. So it's not that much work. To combine these, we just get a common denominator. Both denominators already have a 2, and they already have an x to the 1/2. So we just need to turn this x in the first fraction into x to the 3/2. Turn this from x to the 1/2 into x to the 3/2. How much more xiness does he need? 1. So just multiply this by a full x, and that gives you 3x over 2x over 3/2. So that's getting yourselves together into a single fraction. Do you need to do that? This is fine. Now, Risa did what I would have recommended, similar to 47. Break this apart into 2 separate terms. You can do that because your denominator is only a single term. And then you avoided quotient rule. You didn't have to do it that way. You could do quotient rule, but then you'd have like quotient rule with fraction and negative exponents thrown in there. Yuck. 43, who are you? Akshay, go. Now, the answer key says something different, doesn't it? Yeah. The answer key says tangent squared. Now, how is it allowed to say that? Well, let's go back to our trig identities. Fill in the blank. What is 1 plus tangent squared? Equal to secant squared x. So that's one of our 3 Pythagorean identities. Where did that come from? What's the main Pythagorean identity? Sine squared x plus cosine squared x equals fill in the blank. 1. How do we get from here to here? Well, if we want to get secant squared thrown in there, what do we have to divide 1 by? Cosine. So if you divide by cosine, cosine divided by cosine is 1. Sine divided by cosine is tangent, and 1 divided by cosine is secant. So just divide everything through by cosine squared, and there you go. Now, you look here and you say, well, this has negative 1 paired with secant squared. If you subtract the 1 over in this identity, you get tangent squared by itself. So you can do that. Is that necessary? Do you have to do that? No, but it's a little bit simpler. Right, sir? Yep. If you divide it through by sine squared x, you would get 1. And then what's cosine over sine? What is it? Cotangent, so cotangent squared. And what's 1 divided by sine? Cosecant. So these are your 3 Pythagorean identities that you should be able to use, recognize, rearrange as necessary to fit the situation at hand. So like here, it's not as you see it. It's a trig identity that's been rearranged a little bit, but it's still applicable. So these are 3 of the trig identities that I think you ought to know. So write them down, turn them into flashcards, know them, love them, and get comfortable. Rachel, talk to us.
Which is 2x minus 2x to the fourth minus 7x cubed minus 5x squared minus 30x. And then I there's the derivative of all of those.
Good.
That's supposed to be y from.
Well, I don't even know if it's called y or f, but you know what it means. You labeled stuff, it's a reasonable label. So, could you do product rule? Yeah. Is it going to be fun? No. So distribute it out, because you can distribute this out fairly easily, and then it's just basic power rule. Comments, follow-up? Door, please. Dice. 1, 4, 6. So, rows 1 and 4, please hand in your homework. Leah? Also, hi. Also, Lamia?
Yes.
Thanks. Did I tell you guys when your next quiz is?
No.
Okay. I don't know. But probably sometime next week. We'll say Thursday, Wednesday, something like that. And it'll probably be on mostly 2.3 and 2.4. Yes. I don't know. I'm hoping not to slow down too much, but we can, like, as we get into AP exams, I'll ask what exams people have, like, tomorrow, and if it's like 2/3 of the class, we'll adjust accordingly. If it's like one person, sucks for you. On the moon, is there gravity?
Yes.
Okay, good. I hope nobody says no. There's no gravity on the moon. Yes, there is. If you tell me that there's no gravity on the moon, I'll tell you, get your butt down to physics so they can fix you. So there is gravity on the moon, but there's not air, so don't, like, try to breathe. Well, actually, go ahead and try to breathe, but it won't be any good. So the nice thing about no air on the moon is that you drop something and there's no air resistance. So you can go up on the moon. Well, you can't, but somebody rich can go up on the moon with like a hammer and a feather and drop them both, and they'll fall like rocks at exactly the same rate. Not like here where you drop a hammer and a feather and the hammer just boom and the feather goes, all right, because it's got air resistance. That's why birds are able to fly. I don't think they'd be able to fly on the moon because no air resistance for them to fight against to get airborne with their wings. I guess they could fly if you like throw it, but then it's going to come back to the ground. So I don't really know if it's flying so much as falling. So no air on the moon equals no air resistance, so things fall at the same rate no matter what it is. So here's your dropped object equation for the position of some object on the moon. So you drop some object and it falls in such a way that this is its height after t seconds since you dropped it. And we're going to be measuring things in meters. So first of all, from the equation, what is your initial height? How did we get 2? Yeah, Just plug in 0. So initial means at the beginning, and at the beginning is times 0, and that's 2. So initial height, 2 meters. Done. Next, finding the acceleration due to gravity on the moon is just finding the acceleration of that function. How do we go about finding the acceleration when we start with position? Derivative. Now, when we get the derivative of position, what will that be? Velocity. But we want acceleration, so take the second derivative. You do the derivative again, and then you'll have acceleration. So over here, part B, we take the derivative, s prime of t, and what is that? It starts with a negative. You're welcome. Lamia, so what do we get when we take the derivative? Negative 2.81. So you multiply numbers by just taking a number that's multiplying and sticking it in front. So now 0.81 times 2 is now negative 2.81. It's a new trick. I wish it were that easy. So what is it really? 1.62. So negative 1.62 t. Just that's it. Yeah, plus 2 goes away. And what did we say this is? Velocity. So to get acceleration, we take the derivative again. We call that the second derivative of position, s double prime. And what's that going to be? I'll stick with you. Negative 1.62. That's acceleration. What do you notice about our position equation? Our acceleration equation? It's just a constant. Because when you're falling at a constant rate. Well, that's not true. You're falling with constant acceleration. You're speeding up at a constant rate. So that's acceleration due to gravity. What are the units for acceleration? Well, let's think. This is time in seconds and height in meters. So the velocity would be in what? Meters per second. And the way differentiation works is you just tack on a per time every time you differentiate. So acceleration is what? Meters per second, which is awkward, so we write meters per second squared. What we don't do is say meters squared per second, because that's the rate of change of some area over time. So it's not relevant here. So if you wanted to do the next derivative, that would be meters per second per second per second, which we probably just called meters per second cubed. But we don't care about that. We just stop at acceleration, meters per second squared. That's the units. So next we want to compare, well, how is that like different from the Earth? So if you're in physics class, you know that the gravity on Earth in meters per second squared is negative 9.8 meters per second squared. So if we want the ratio of Earth to moon, we just say, all right, negative 9.8 divided by negative 1.62, and what is that? 6.049? I call it 6-ish. So you speed up about 6 times as quickly on Earth when you fall down on the moon. Assuming, again, no air. So if we like suck all the air off the moon, Earth, and then drop you, that's how it would go. Now, unfortunately, here we have air. Maybe not so unfortunately. So air is going to be slowing you down a little bit. So it's a little bit less than 9.8 meters per second squared for gravity on Earth. Depending on what your air resistance is going to be. It's going to be like how feathery you are will probably have something to do with that. Yeah, how feathery, like how much feathers you have.
Okay.
Like if you go grow some feathers, turn into a bird. So, ta-da! Let's do a population growth problem. What? Huh? So population of what kind of animal? Humans, dogs, E. coli? This says bacteria, so pick your favorite bacterium. E. coli? All right, E. coli. Everybody's favorite. a population of 500 bacteria is introduced to a school, like in the biology lab in a petri dish, and maybe that's the best thing for it. And grows according to this equation. P equals 500 times 1 plus some ugly fraction of 4t over 50 plus t squared. And t is measured in hours. T in hours. So over a period of time, the amount of bacteria in our school grows according to this function. And bacteria aren't great about like population control and like contraceptives and stuff, so they just like go, and we're off. So we want to know what's the rate of change of the population. So goal, find rate of change of population at time 2 hours after they've been released into the wild. And this is the sort of thing that demographers will use when they want to study populations of people, or when biologists, ecologists will use when they want to study populations of like wild coyotes and the deer. It's like, hey, there's too many deer in Pennsylvania. All right, let's release the wolves. That'll be the humane way to deal with it. No, we don't want to hunt. Wolves will take care of it for us. They actually did that in Bloomington, Indiana. Because why? Because they did have a deer problem. Deer can like destroy an ecosystem real fast. They just eat everything. Yeah, so wolves are the safer option. So if we want to find the rate of change of the population, or the rate of change of anything, what does that actually mean we need to do? Derivative, because rate of change is fancy talk for slope, and derivatives are slopes. So when we want the rate of change, that merely means find p prime. So let's go back to our equation and think about how we're going to differentiate this. What would maybe be a good first step? Distribute the 500 seems a good idea. So distribute the 500, we get 500 plus what? Lamia, what's 500 times 4? Yeah, 2000. 2002, what? I'll just pick on it. He's fine. All right, so you get 2000t over 50 plus t squared. And then if we go ahead and differentiate this, what happens with 500? Disappears, goes poof. And what do we do with fraction? High, low, low, high, except what is it really? Low, high, high, low. So low starts with low. Low, high. So you guys do that. Oh. This is not tonight's homework. You're welcome. Yeah, right now. Whatever you think is the most reasonable. All right, so what is low D high going to look like? Sahil. What's this going to look like when we set up our quotient rule on top?
P plus P squared times 2000 minus 2000P times 2T.
Thank you. And when we go ahead and distribute that mess out and then combine like terms, what's our numerator look like at the very end? Joanna? Wait. Okay, pause, questions? So low, D high, minus high is 2000 T, times D low is 2T. So did you just forget that there was a T on top of the 2000? Oh, okay. That would work, but be awkward. I don't even want to tell you because it's just going to be confusing. So, Joanna, what's the numerator when all said and done? $500,000? 100,000. That makes more sense. So 100,000, and then what did you say? So plus 2,000 and minus 4,000. So I'll just call it minus 2,000 T squared. Let me combine them. You want to simplify that? Yeah, me neither. All right, so then that's a derivative, and then what do we want to do with it? Plug in 2. So that's a T prime of 2. When we plug in 2 for our time, what do we get? Anybody have that yet? No? I factored out 20 or 2? 30,000. Okay. So what is this? Say again? 31.55, and units, bacteria, is what we're measuring, and this is over a period of time. Time is measured in hours. So like how position was measured in meters, and then we took the derivative, and time was in seconds, so it was meters per second. Whatever the thing is that we're measuring, here we're measuring bacteria, and then we're changing over time. So it's bacteria per time, time is an hour, so bacteria per hours. So at time 2 hours after we've released the bacteria, they're increasing at a rate of 31 bacteria every hour. And then we could plug in another time and see, is that rate of change increasing or decreasing? Are they growing at a faster or slower rate over time? We don't need to do that. Questions with 87?
You're gonna have to do that on homework again.
No. 99. Get the first derivative. Then get the second derivative from the first derivative. Go. You guys can raise me. You win good work. Yes, you win. All right. Being good at stuff is cheap. All right. So first, second, plus, So. Yes. Yes. All right, cool. So that's your first group. Now to get your second group. This guy, you want to differentiate this guy. And then this guy, you can do product. Product is just Good stuff. All right, time says we got to move on. So what rule do we have to use to get our first derivative? Product rule. So first times d second plus d first times second is sign. There's your first derivative. Questions with that? Then you differentiate again. This guy needs product rule a second time. The second term is fine. You can differentiate the second term. It's cosine x. So when you do product rule on this first term, first times d second plus d first times original second. What's the matter with me? I keep doing that. So d first is 1, original second is cosine, so that's 1 cosine x. And then those guys combine and make 2 cosine x's, and this is a negative x times sine of x. So that's y double prime. So that's where you should end up. Any questions with second derivative? I can give you information about 2 functions like this. You don't know anything about g and h except what they are and what the derivatives are at 2. So then I can create other functions in terms of g and h and ask you about those functions' derivatives at 2. So if I said, hey, what's f of prime of 2 if you know that f equals 2 times g plus h, first of all, what's f prime of x? So what's the derivative of 2g? 2 times g prime plus h prime. Any need for product rule? No, because it's just nothing's getting multiplied that both involves x. So that's it. And then you just plug in 2 and say, oh, I know g prime of 2, I know h prime of 2, and you're on your way. Over here, what rule would we have to use before we can evaluate this? Here we have to use quotient rule. So you'd say low d high minus high d low over low low. And then you can take this information and plug it in where necessary. So you know h of 2 is right there. You know g prime, it's right there, and so on. So if you see something like this, whether on a homework or a quiz or a warm-up or wherever, use your differentiation rule. Sometimes it's as simple as, oh, just g becomes g prime and h becomes h prime. Okay, that's cool. Sometimes you got to use your quotient or product rule. Pay attention to what's getting divided or multiplied, and then take the information and dump it in and evaluate. So you have another homework for tonight. Last night with chapter 2.3. Tomorrow we'll go over the homework and start chapter changing. 2.4. When are we out of here? 40? Okay, yeah.